Hey physics friends, today on 17.2, what I'm going to be talking to you about today is how do you use your compass and a straight edge to reflect a line accurately off of a mirror. Because you're going to be doing that. I'm going to be tracing a mirror, if it's a flat mirror, if it's a curved mirror, and you have to reflect a laser beam off that mirror. So there's a couple of steps to do this. Now, the first thing before you get started doing any of these, and probably one of the biggest mistakes I see people doing, is that you need a very sharp pencil. Your pencil needs to be sharp. When you do, if you have a flat pencil, when you go to make your lines, they're going to be really fat, and you're trying to be accurate where two lines cross, and you've got a big fat line and a big fat line, and there's lots of area where they cross. You have to make sure that you have a sharp pencil. Not only that, when you draw your line, twist your pencil as you draw the line, and that will actually sharpen your pencil as you do it, and it'll give you a nice fine hairline, razor's thin line when you're doing it. Thing number two, to ensure accuracy, this compass you've got, it cannot be floppy. If this thing flops around at all, when you open it up to set to strike an arc, it needs to stay set. So if it moves around at all, you have to, if there's sometimes there's like a nut right here, you can get a little wrench and you can tighten that up, or there's a rivet and you put a nail and you hit it with a hammer to open up that rivet, and you'll get it a little bit more tighter. If you have problems with your compass, come and see me, and I can usually futz around with them to get them to work pretty well. And also, the pencil that you have in your compass needs to be sharp as well. One technique that I sometimes use is I'll take my compass and I'll just at the piece of paper, I'll use my piece of paper as like a sanding board to get that edge nice and sharp when I do my arcs. So let's get started. Here's the scenario. What you've got is you've got a mirror, and so watch me as I twist my pencil as I drag it across, twisting your pencil. This is my mirror. How do you reflect a ray off of that? So let's just draw any old random ray, twisting the pencil, coming in. So this is my incident ray. Strikes my mirror. How do I draw that thing reflecting off of here accurately? There's an algorithm. We do this in geometry. It's really, really cool. This is probably one of the most powerful tools any mathematician has, is the compass. And if you see the Freemasons, they had this, the compass and the square is their insignia. What you do, open your compass up to any old angle. It doesn't matter what span this is. It can be completely random. You're going to put the pointy part where these two things intersect. Well, the first thing actually what I'm going to be doing is constructing the normal. So this is the first step, is constructing the normal. In order to do that, so you put the pointy part here, and you strike two arcs on either side of your intersection. So all I did, these have to be the same. Now if your compass moves, that's going to be bad. Strike an arc on the right, strike an arc on the left, and you're good. The second thing I'm going to do, now I'm going to open up my compass to a larger angle. And the bigger the better. A lot of people, a third mistake people make besides sloppy compass, dull pencil, is that they try to make their arcs really small. The bigger the better. Open that compass up, get a really nice big span on your compass when you go to do these pieces. So now what I'm going to do is I'm going to put the pointy part on this intersection, and I'm going to strike an arc up above, like this. And then I'm going to go and do the exact same thing over here, like that. And then what I'm going to do is connect this spot right there where they intersect to right here, and that will be perfectly 90 degrees. So I take out my straight edge, and now I'm going to do a special line that's going to go long, short, long, short, long, short, long, short. And I make sure the long goes through my intersection, short, long. this is a perfect right angle. You've constructed it that way. And this is kind of what we did in geometry terms is called, we made a perpendicular bisector. We literally, this piece right here is exactly the same as that, and this perpendicularly bisects that segment. So there we go. We've constructed the normal, and there's a process to do that. The second thing I'm going to do is now copy my angle. Copy the angle of incidence. Now, the way to do that, and that's pretty clever because the law of reflection says that this angle right here, this angle of incidence, is going to equal the angle of reflection. So the way you do this is you put the pointy part right here at this intersection. And what I'm going to do is open up my compass to some random span. It doesn't need to be any place, it just needs to stay still. Open my compass to a random, and I'm going to strike an arc all the way across here. And what I need to do is copy this angle right here. So I'm going to take my compass, put the pointy part right here, and I'm going to physically measure this spot right there. So I'm going to bring my compass in, keep the pointy part, and you see how I've matched that right there? I need to copy that angle. So then I just take my compass over here, strike an arc, and now this angle equals this angle. Go back to my pencil, twist it as I draw it out. There's my reflected ray. And that's how you reflect something off of a flat surface. So what I've done is this angle right here equals this angle right here, and I've got perfect reflection. I'm going to do it one more time in real time to just show it you one more time in case you missed something. So we're going to start over, and I'm going to go a little bit quicker. Let's see if I can zoom it in a little bit too. So first thing, draw my mirror, twisting the pencil. I've got a ray, just a random, let's make it a little bit larger this time. Here's a ray that comes in and intersects the mirror. First thing I do, I open my compass up to some random span, strike an arc on one side, strike an arc on the other side, open my compass nice and wide, going to strike an arc above, strike another arc above. I'm going to connect these lines. Long, short, long, short, long, short. I want you to do the long, short thing too. It's a little thing we do in engineering that represents the center. A line that has this pattern means it's a divider of something. Next thing I do, I'm going to shorten up my compass, make it a little bit shorter. And I'm going to draw an arc. Then I need to measure this span right here, so I'll adjust it so my line goes right through that intersection right there. Measure this span. Come over here. Measure this span. Draw it. Here's my reflection. There it is. It's pretty simple. It's really fun. It turns out this exact same method works for curved mirrors as well. So if you've got a convex mirror, a concave mirror, a flat mirror, you literally do the exact same thing. If it's a spherical curving, meaning like it's not a parabolic curvature. So anything that's like a round, if it conforms to a circle, that will work with this convex or concave. Now, I encourage you to practice this. You've seen me do it a couple times, but until you physically do that algorithm 3 or 4 times, it becomes habit. It's really easy because there's a few steps in there, and if you don't take the time to practice this, it's real simple. Draw your mirror, draw the ray, can you reflect it? You could use your protractor to actually measure, does this angle right here equal this angle right there? And that would be a way to kind of check yourself.